Hi again, I'm Michael from Leo Robotics here with another update about Leo, the bipedal walking robot. So last time we actually made a really big step in Leo's journey, pun intended. But really, we got him to take a few steps. He was in a walker, but hey, I'll take what I can get. If you haven't seen that video yet, it's really cool. I suggest you check it out right here. But in this video, I'm going to explain how I fixed him and about a new remote that I made. So if you remember from update video number 2, one of Leo's motor drivers actually started smoking. So I've had to replace all of the motor drivers and rewire this entire area. It's taken a while, but it's been worth it. The new motor drivers are right underneath here. Just as a size comparison, this is the old one, and that's the new one. It's kind of hard to tell on camera, but these are much bigger, and the heat sinks are also very much bigger. So these ones haven't even started heating up at all. They can carry way more amps than these can, so these are a much better choice for Leo. So I explained all of that in just a few seconds, but it took me almost a week to actually do it all. So these things are not as easy as they seem. But now on to the interesting part of the video, the new stuff, right? Here is the remote that I made for Leo. So as you probably guessed, I did not make this device myself. This is a Kindle Fire from, it's gotta be like 10 years ago. But this is my mom's old one, and she's not using it anymore, and it's also the biggest touchscreen device we have in the house, so it works. So since the Kindle Fire can take APK files just like an Android phone can, I use App Inventor 2, which is a website online which is really useful, which I've used to build a lot of apps for my phone before, and I use that to build a simple remote for the Kindle Fire. As you can see at the top, there's an IP address and a port. This is how I connect to him. Next, there's a lot of squares. So these are all different colors just so that I can remember which button goes with which function. And on the right, there's a slider tool with a green button next to it. So I set the value I want with the slider, and I hit the green button, and that will send it to Leo. Then in the upper left-hand corner, there's a toggle switch. When I turn that off, a big stop button appears. This is an emergency stop button that I made that will stop Leo remotely. This isn't nearly as reliable as flipping the switch on Leo himself, but it's still nice to be able to do it straight from my remote. So one thing that I had to sort out with the remote is that what if I don't want all these buttons to do the same thing all the time? Like, when I'm testing it, I want to be able to change what the buttons can do. I don't want to have to update the app every single time that I want to change a function. So to do that, instead of sending a function that I want to do on Leo through the remote, I just literally send the color of the button that I pressed. Then inside of the script that I wrote, Leo will decipher what each color means, and I can easily change that while I'm changing his walking algorithm. So I'm not going to go into nearly as much detail as I went into last time about the code, but basically, when I start the script to make Leo walk, it'll also start a server which listens for commands from the Kindle Fire. And as it gets commands from the Kindle, it will change values in the script while Leo is still moving so that we can get live responses from him. So I just started the script on Leo to just keep his legs straight to the position that I set him to. So if I push this yellow button, it will bend his knees. If I push the green button, it will straighten his knees. Currently the other ones don't do anything. That's because they're all programmable in the script that I'm writing, which is the same script which does all of his walking algorithm. I also added in the slider on the side, so if I go all the way up to the top, that'll bend his knees all the way. And if I go all the way down, that'll put him up. But if I go halfway, that'll push his legs out a little bit more. If at any point I push the stop button, it will instantly cut out all of his motors. This literally cuts off the entire script, so there's no way for me to turn it back on until I restart the script, which will reset his position. So now I can use this again. So all in all, I'm really happy with how this has gone and how the Kindle Fire has actually been able to help me get Leo working better, because before I could only input things into the same terminal that Leo was outputting data, and that just became a mess. So I'm really glad about that. So Leo is actually doing a lot better than I expected him to do. Over last year, I barely made any progress on him, honestly. So I'm really happy with how far I got him to go in the last video. To be honest, what happened in the last video wasn't really walking. And for anyone who knows anything about dynamic stability or anything like that, they'll know that that was really fake. I mean, the walker was holding all of his weight. All he had to do was pick up a leg, move it forward, drop it down, and then shift his weight forward. And repeat that over and over again. So a comment in the last video actually asked if all the code I've written to make him walk in the walker was relevant to his future walking algorithm, and the basic answer is no. The code that I've written to be able to get his legs to the position I want them to go to, all is still relevant, and I'm going to continue to fine-tune that in the future, but everything I wrote to make his leg pick up and move forward and everything is going to be trash when I start working with real dynamics. So when I say real dynamics, it means that he is actually actively changing based on what is happening with his walking. So let me break that down. When he was in the walker, he was on fixed timers. That means that after 1 second, he moves his leg this far. After 2 seconds, he moves it this far. 3 seconds, and so on. But if you were to turn him upside down or put him on a side or something, he would do the exact same movement with his legs moving forward. And that's not how a human walks. A human's not going to try and walk if they're laying down on the ground. So what we need is something inside of Leo that can tell him how he's oriented in space. And that's called a gyroscope sensor. You have one of these in your phone that senses when you turn your phone sideways, so it'll go into landscape mode automatically. I'm going to be using the same thing for Leo, except for instead of just having it orient sideways or not, I'm going to be telling how he's positioned to tell how far he is into each step, so that I can figure out when he needs to put each foot down on the floor. In addition, I'm also going to put one gyroscope sensor inside of each of his legs in order to fix this issue. Look at that. That's really a problem. And the only way to really fix that is to figure out how he's positioned in space, not relative to his own body. So the gyroscope sensor in the body is going to capture its position, and then we're going to get the data from the gyroscopes in the legs, subtract that position from the gyroscope in the body in order to figure out how he's actually oriented and if his legs are sagging together at all. If they are, then we need to change his position that I want him to go to by the amount that he's sagging in the negative direction. Not sure if that made sense, but it'll work in the code, don't worry. So anyway, that is the next step, is going to be putting in gyroscope sensors into Leo, and hopefully maybe also getting rid of this Arduino, because that's really slowing down the code on the Raspberry Pi, because it has to wait for the Arduino to respond every single time. So that's just about everything for today's Leo update. If you've liked it, consider giving a like, and if you're interested in Leo and about the progress I'm making with him, I'm going to keep on making videos, so be sure you subscribe. But anyway, that's about it for today. Bye.